We've got a pretty good handle on how to solve systems of equations. We've used graphing, we've used elimination, we've used substitution. I think most people would agree that elimination is probably the easiest technique to use. So we're going to be solving them in context. So this is section 2.5. And here's the warm-up. It's just a very simple question. It says, do you agree or disagree with this statement? Life is complicated. Well, it probably doesn't matter how old you are, how much experience you have. You've probably run into some things that make it seem like life is really complicated. So we're going to go ahead and circle this right here, and we're going to say that it's complicated. It is definitely complicated. So definitely. It's definitely complicated. Now, here's the cool thing about this. There are a lot of things in life that are complicated, but if we stick with it, put some pieces together, work really hard, we can usually solve a lot of the problems that we come across. And we're going to be working on some problems that mimic some of the difficult problems that you might see in real life. Now, you may not solve math problems exactly like this, but you are going to be using your brain in a very similar fashion. So they're going to seem like they're complicated, just like the problems that we see in life, but just make sure you don't give up. So to solve these problems, we're going to need to be really organized, and we're going to need to show our work, and we're going to need to show our thinking. So one way that we can keep things organized is we're going to say this word, we're going to define the variables. So we define the variables, and sometimes people call that declaring the variables. What it means is that we're going to write down the variables that we're going to use. Usually they're going to be X and Y, but not always. And we're going to state what they represent. So we're going to make sure that everybody knows if we're using X, we're going to say what X represents in the context of that real world problem, and what Y represents in the context of that real world problem. Okay. Then we're going to write two equations for each problem. That's what's going to make a system of equations. And remember that most story problems end with a question that tells us what we're looking for. So it's going to actually remind us, hey, this is what I want you to find, and that's going to be a very good hint as to what we're going to be using for X and Y, at least what we're going to use to declare those variables. One other thing that's important to keep in mind is that most of the problems we're going to be solving, they're going to give us information about two different parts of the problem, or two different aspects of the problem. So let me give you a couple of examples. Sometimes they're going to be talking about the total number of things and maybe how much the total cost was. We'll be talking about a trip on the way there and a trip on the way back, or maybe the number of animals and also the number of legs. And you'll see what I mean about that type of problem in just a minute. So keep this in mind as you try and write the two equations for each one of these problems. So I'm going to slide down here. I've got four problems that we're going to take a look at, and I've got some notes on each one of these. We'll take a look at these as we go through these. So the instructions say write equations for each problem. Be sure to define the variables, then solve the problem and state the answer. So this means this is that organization part here. We're going to make sure that we define those variables. We're going to write down the equations using those variables. We're going to show how we found the solution, and then we're going to state what the answer is. Now, before I read that, let's just take a look at this note. We mentioned earlier there are several techniques that we have for solving systems of equations. So you can use substitution or elimination. Graphing's probably not going to be the best way to do these, although if you wanted to use your calculator, I suppose you could. Usually we want to see the algebraic work. So please make sure that you show that. So it says in Jacob's piggy bank there are 250 dimes and quarters worth a total of $39.25. How many dimes and how many quarters are in the piggy bank? So 250 dimes and quarters worth a total of. Now they're not 250 dimes and 250 quarters. What this means is that in total, if we add the number of dimes and the number of quarters together, they're 250. And then if we add how much they're worth, it's $39.25. And again, here's the question. How many dimes and how many quarters? So here's what I'm going to do on this one. I'm going to say D equals dimes. Now, if I wanted to, I could say X equals dimes. Normally, the first one, we're going to let that equal X, and the second one, we'd let that equal Y. But in this particular case, it kind of makes sense if we actually use the letter that starts with the word that we're looking for. So D for dimes and Q for quarters. Now, like we said just a second ago, there are 250 dimes and quarters. So that means if you put those together, in other words, if you do the dimes plus the quarters, we get 250. So we've got this part taken care of. So you'll notice that this is about the total number of coins that we have. And then we've got a total amount of money. And this is where we need to think about this for just a second. It's going to take a while to get used to how we do these types of problems. And again, usually the toughest part is writing down the equation. The solving part is usually going to be not that bad. So we want to think about, if you've got a dime, how much is a dime worth? Well, it's worth 10 cents. So what we're going to do is we're going to take each one of those dimes and we're going to multiply them by 10 cents. Now, I realize that you could write 0.1d instead of 0.10d, but when you write 0.10d, it just reminds us that that's worth 10 cents. It's also a really good placeholder when we start using the technique of substitution or elimination. A quarter's worth 25 cents, so we're going to do plus 0.25q. So this right here is representing how much the dimes are worth. This is representing how much the quarters are worth. And then in total, when we add up, whoops, I need a zero there, 250. In total, we have $39.25. So $39.25. So we've declared the variables, we've defined the variables, we've written a system of equations. One of these equations is about how many coins, one of the equations about how much they're worth, and now we're going to go ahead and solve this, and then we'll state the answer. Now, it looks like on this one, we could solve this one using substitution if we wanted to just move the q to the other side or move the d to the other side. I think you'd agree most people like to do elimination, so I'm going to go ahead and use elimination on this one. So I'm going to multiply this by negative 0.10. And again, a reminder here, the reason we're going to multiply this by negative 0.10 is because if that's 0.10d, I need this one to be negative 0.10d, negative 0.10d, in order to cancel that out, in order to eliminate. So here we go. Let's go ahead and multiply. So I'll multiply by each one of those. So we get negative 0.10d. Again, I like the way those things line up. It's really helpful here because that's going to make the 10 go right underneath the 25. And then we have 0.10 times 250. That's going to give me 25 right here. And then we can just go ahead and combine these together. So this is going to be 0.10d minus 0.10d. Those are gone. We eliminate those. 0.25q minus 0.10, 0.10q is going to be 0.15q. And then over on the other side, we're going to have 39.25 minus 25. Oops, I need a minus on there. Got to make sure I don't make that mistake again. Okay, so we've got a minus right there, and then this is going to be 14.25. Okay, now I want to pause for just a second, and over on this side right here, I'm going to show you a very common mistake. If we were to leave off the zero there, which some people do, and I ended up multiplying by 0.1, a lot of people will stack this on top of each other, and they'll do 0.25q minus 0.1q, and they won't line up the tenths place. So if you don't line up the tenths place, somebody might be tempted to do this and write this down as 0.24q, and that's definitely going to be a mistake, and we're going to get the wrong answer. So let me just make sure we're on the same page here. We've got this equation which says there's 250 coins altogether, this equation that says they're worth 39.25 altogether. We took this equation right here, we multiplied everything by negative 0.10, so that gave us negative 0.10d, negative 0.10q, and negative 25, and then we've got this right here. Now, if you need to grab a calculator for something like this, there's no problem here. This still counts as showing your work and stuff like that. So I'm just going to grab this calculator, and I'm going to do, because we need to divide by the 0.15, so we're going to divide by 0.15, and I'm hoping that this works out pretty nicely. So let's check and see here. So I'll bring up the calculator here, and we're going to throw in 14.25 divided by 0.15, and we end up with 95. So Q is equal to 95. Now remember, that's the quarters right there. So here's what we're going to do, and I'm going to change colors just so we can keep this straight. We know that there's 250 altogether, so this is going to end up being a quick subtraction problem, but I'm going to put that 95 right here. So we're going to get D plus 95 equals 250. So we're going to subtract 95. So we're going to get D is equal to, this would be 155. Now that's the answer to the system of equations. Q is equal to 95 and D is equal to 155. We don't have to write these as an ordered pair because what we need to do is we need to state what the answer is. We need to say what this means in the context of the problem. So what this means is there are 155 dimes and there are 95 quarters. And we can circle that and we are all finished. Now, like I said, these are fairly complicated problems, and you might look at this and go, my gosh, there's a whole bunch of work here. I'm not sure I wrote down the equations right. I'm not sure I've got the right answer. There is a way we can kind of check and make ourselves feel a little bit better about this, and that's to go through and say, look, what we've said is I've got 155 dimes and 95 quarters. Let's add those together, 250 coins altogether. And then let's do this. Those dimes right there are worth 10 cents. So let's do 0.10 times 155. And then let's add what the quarters would be worth. That's 0.25 times 95. And if we multiply those together, we get $39.25, which is the correct amount of money. So I think we're in good shape there. So let's go ahead and take a look at the next one. This one says a 96-inch board is cut into two pieces. The long piece is 14 inches more than twice the short piece. How long is each piece? Now, a little hint here, because this is a very short question, but it can seem very complicated. On problems like this, it's often helpful to think in terms of which piece is bigger and which piece is smaller. So what do you need to do to the small piece to make it as big as the big piece, or vice versa? So here's what I'm going to do. We need to declare variables. So we're going to write x equals, this is the short piece, and then y is going to equal the long piece. Okay? Now, one thing we definitely know about it is we take these two pieces and we get a 96-inch board. We had this 96-inch board, we cut it in half. We've got x over here, we've got y over here. If you were to add those together, you'd have 96 inches again. So we've got x plus y is equal to 96. And I just noticed I've got a typo here. This second one should say the long piece is 15 inches more than twice the short piece. So we're going to go ahead and go with that. So what that means is the long piece, so that would be y, is means equals 15 inches more than twice the short piece. So this is kind of telling us what we need to do to the short piece to make it as long as the long piece. So we're going to take the short piece and we're going to double it. So that's going to be 2x. And then we're going to add 15 inches right here. So these are the two equations. Here's our system of equations. And now this is set up to solve by substitution. You can see that we've got the y all by itself. So wherever an equation asks for a y, we can put 2x plus 15. So I'm going to take this and I'm going to put it in right there. And then we're going to substitute. So we get x plus, here's where the y is going to go, 2x plus 15. So instead of putting y right here, we put what y equals, which is 2x plus 15, and then that equals 96. Then we're going to finish solving here. So we've got 3x plus 15 equals 96. We're going to subtract the 15 from both sides, so we get 3x equals, and we get 81 over here. So we're going to take 3x equals 81, and we're going to divide by 3, so we get x equals 27. So we know what x is. Now we're going to take that and we're going to figure out what y is. So I'm going to take this and I'm going to plug it in right there. So we're going to get y is equal to 2 times 27 plus 15. So that's 54 plus 15. Oops, 15. So 54 plus 15, that would end up being 69. So y is equal to 69. So again, we've got the two answers here, but we want to answer this in the context of the problem. So we're going to say the short one is 27 inches. So short one is 27 inches. And the long one is 69 inches. Okay, so we've got that one taken care of, and we are on to the next one. So let's take a look at that one here, and this is the one about animals. So let's pull this up and take a look at what we've got here. Okay, so on this one it says there are 12 animals in the barn. Some are chickens and some are sheep. There are 28 legs in all. How many of each animal are there? Now, I've got a little thing over here. This is true generally of pretty much every problem that we're going to see as far as solving equations in context or systems of equations or anything like that. Each problem is going to be slightly different. They're all going to have their own little flavor. If you practice enough, you're going to be able to recognize what you need to do, but it does take a lot of practice with lots of different problems. Each one isn't a completely different type of problem. There are going to be some similarities with what you already know how to do. So let's take a look at this one. I want you to notice that there are two numbers here. This number right here represents how many animals there are, and this number right here represents how many legs they have. So we're actually going to have two equations here. One is going to be about the number of animals. The other one is going to be about the number of legs. So I'm going to write down x equals chickens. and I'm going to write y equals sheep. Now, if you wanted to use C and P, that would be, or sorry, C and S, that would be totally okay. There's not a problem with that at all. So on this one, we're going to say, well, let's see, there are 12 animals in the barn, so there are only chickens and sheep in the barn. So if we take those animals, that many chickens and that many sheep, and add them together, we're going to have 12 animals. And then let's stop and think about how many legs each one of these have. Well, chickens only have 2 legs, so we're going to take the number of chickens and multiply that by 2. So 2x represents how many chicken legs there are. And then y represents the number of sheep, and every sheep has 4 legs, so we're going to multiply 4 times y. So if you take the chicken legs and add them to the sheep legs, you end up with 28 legs altogether. So here's the system of equations. So we've declared our variables, we've written our system of equations. Now we're going to go ahead and solve. Now, you could solve this one using substitution if you want to. Again, I'm going to solve this one because we just did one with substitution. I'm going to solve this one using elimination. So I'm going to multiply by -2. That's going to give me -2x, -2y, and that's going to give me -24. The x's are going to go away, so we end up with, we end up with 2y equals 4. And then when we divide by 2, we end up with y is equal to 2. So we're going to take that and we're going to finish solving this. Again, I'm going to change colors for clarity here. I'm going to plug that in right here, and it really doesn't take much effort here. We know that x plus 2 would equal 12. If you know that this one is 2, the other one's got to be 10, and we can kind of verify that by going through the steps right here. So there are the 2 answers, but again, we're going to write down what the answer is in the context of the problem. X represents chickens and Y represents sheep. So 10 chickens and 2 sheep. Now, it's easy to tell that we have 12 animals altogether, but let's just double check this here for a second. I'm going to pull this up, and we're going to do, let's see, let me get out of here, clean this off. If I have 2 times the number of chickens, because that's going to be how many chicken legs we have. If we have 10 chickens, then we have 20 chicken legs. And if there are 2 sheep and they have 4 legs apiece, there's our 20 plus 8, so we've got our answer right there. So we can feel pretty confident that we've got the right answer. Okay, on this last problem, this is just kind of a classic algebra type of problem. It says when Amanda goes paddling in her kayak on the Snake River, she can go 11 miles per hour downstream, but only 4 miles per hour going upstream. How fast can Amanda paddle, and how fast is the current? So when you're doing a problem like this, you've got to keep a few things in mind, and that is what influences how fast you can go when you're in a river that's moving. Well, if you're in a boat, it's going to be the speed of the boat, or in this case, the paddling, that's going to have one impact on how fast you're going, but also whether you're going upstream or downstream and how fast the current is. So in this case, I'm going to write down the paddling and the current. And it's going to be important to write these down in the correct order. Now, when she goes paddling in her kayak, she can go 11 miles per hour downstream. So downstream, and I'm going to write that here, downstream, here's what's happening. She's paddling, and then the current, stop and think, is that helping her speed, or is that slowing her down a little bit? Well, when you go downstream, you're going with the current, so we'd actually add the current here, and she can go 11 miles per hour. And then when she's going upstream, she's still got to paddle, but now the current is working against her. So it's not going to add to her speed, it's going to subtract from her speed, and that's why she's going slower. That's why she's only going 4 miles per hour. So here's the equation here, and I want to point out one thing. You've got to be very careful about the order you put these. You can't do C plus P and C minus P. It's got to be how fast she can paddle plus or minus the current. The current, or in some cases the wind or different things like that impact how fast we can go, that's got to come second. So this is going to be paddling plus the current, or it would be the speed of the boat plus the current, or maybe the speed of the airplane plus the wind, or minus the wind, or whatever it is. But the wind or the current always comes second. Now here's the cool thing about this. You might have already noticed this. This is set up for elimination. We're all set to go right here. So this is going to be 2p, and then on this side we're going to have 11 plus 4, so that's going to be 15. So we're going to divide by 2. So we end up with p equals, this is going to be 15 over 2. Now, this is a story problem, so it would be totally okay if we wanted to write this as a mixed number or as a decimal. So I'm going to go ahead and do 2 into 15. That goes in there 7 times with 1 left over, so that's going to be 7.5. So I'm going to take this and I'm going to plug it in right here, but it might be helpful if we stop and think. In this particular case, let's think about what this means. This actually means 7.5 miles per hour. That's how fast she can paddle. So by changing this to a decimal, it's going to make more sense in the problem, and it's going to make this a little bit easier to solve. So we're going to have 7.5 plus c is equal to 11. We're going to subtract 7.5. I'm going to cancel those off, and if you do 11 minus 7.5, you end up with 3.5. So that's going to be 3.5 miles per hour. So let's go ahead and write down what this means. She can paddle 7.5 miles per hour. The current is 3.5 miles per hour. Now I'm going to circle this, and I just want to do one quick double check here. I want you to think about what this means. We've identified how fast she can go, and we've identified how fast the current is. If we just left it there, we'd probably be okay. But if you can put this back in the context of the problem, you're going to be better able to understand other problems in the long run. So if she were going 7.5 miles per hour downstream and the current was helping her out, we would add these together, just like we indicated here. So 7 plus 3 is 10. 0.5 plus 0.5 is 1, so that's going to give us 11. So we're in good shape there. It definitely makes that first one true. And then if we did 7.5, that's how fast she can go. But now she's got to go against the current, so we're going to subtract that 3.5, and that's going to give us the 4 miles per hour that she was able to go upstream, just like the problem said. Okay, I really encourage you, just like we started out with, these are complicated, but there are lots of complicated things that you're going to have to solve in your life. Please don't give up on these. Please keep working on them. It's not necessarily the math that we're after. It's really the thinking skills that are really important here. So practice these. Work hard. If you've got questions, please make sure you ask and get some help.